So today we're going to talk about Chapter 10, Complex Experimental Designs. This is involving experiments that have more than one independent variable. They may have more than two levels to one independent variable, or you may have more than one dependent variable. When you have an independent variable with multiple levels, you get a more specific gauge of how the variable works with the dependent variable. So if I'm measuring performance based on motivation and I only offer two levels of an independent variable, namely no reward and $4, I only have 2 points. So I will miss any curvilinear relationship that may exist. Since there's only 2 points, I cannot see how the relationship is actually building between the two extremes. If I added more levels of my independent variable, say $1, $2, and $3, then I can do that comparison on now 4 points, so a curvilinear relationship will show. So with this curvilinear relationship, we now know that the relationship between the amount of the award isn't truly linear performance level. It actually increases with increasing award amount for a while, but then it starts to drop off and not increase as dramatically. This can become very important with the strength of the curvilinear relationship. If I only have 2 points and there's a very strong curvilinear relationship, I might not even detect a relationship at all. So if I wanted to measure how often people get asked out based on how attractive they are, maybe I'll use two groups. And I'm only looking at someone who's very ugly, and I look at someone that's very attractive. Well, the very ugly people might not get asked out because they're ugly and people are just less likely to ask them out. Where the super attractive people won't get asked out much because maybe people are intimidated by them, so nobody asks them out. And if I only use these 2 points, I would think that there is no relationship between attractiveness and getting asked out on dates. However, if I add this middle level of an average looking person, then the relationship changes and I can see it's actually curvilinear. So the more attractive someone gets, the more likely they are to be asked out to a certain degree until they get too attractive, and then that relationship starts to diminish. When looking at a factorial design where you have multiple independent variables, hint, hint, for your project, you are doing a factorial design. You have more than one independent variable. With an independent variable, you still have the same problem if you only have two levels, where you can't detect a curvilinear relationship. But a two-level independent variable is the easiest way to set up the experiment. So the simplest factorial design would be a 2 by 2. So here, the 2 is representing the number of levels per independent variable. So we have one independent variable with 2 levels. We have another independent variable with 2 levels. We need people to be at both levels, all combinations of those two. So if I'm looking at sense of humor and attractiveness, maybe I have people who are very attractive and not very attractive, and very funny and not very funny. I need people who are in all conditions. So I need 4 conditions. I need people who are very attractive and not very funny, very attractive and very funny, not attractive and very funny, and not attractive and not very funny. So you need to make sure that you have all 4 experimental conditions. And that's why it's a 2 by 2, is you can actually mathematically figure out how many conditions you'll have. So if I have 2 conditions for this independent variable, I have 2 conditions for this independent variable, I will have 4 different conditions that I am looking at. So there are 2 major selling points of this factorial design. One is efficiency. And basically you can look at the effect of more than one independent variable at a time in a single study. I could do that separately, but it'll take more manpower and more participants to run maybe attractiveness as its own independent variable, and then also run how a sense of humor influences dating as another independent variable, when I can combine them both into this 2x2 and run one single study. The second part, and is very important, is it tells us more about the phenomenon. So we can see how the different variables not only work on their own, but they work together to influence something. So I can see maybe being unattractive sucks and you don't get asked out a lot, but maybe having a sense of humor will account for that. And that's something we can look at when we combine it in this 2x2 factorial design. So the goal of your design is to test the effects of more than one independent variable on some behavior. Instead of running separate studies for each independent variable, you're going to just look at the separate effects of each independent variable, and you have the additional advantage of looking at the combined effects of independent variables. And this is where we get to this idea of main effects versus interactions. The main effects are when you're looking at the individual effects of each independent variable. So maybe I'm only looking at attractiveness by itself, or I'm only looking at sense of humor by itself. And then the interaction is when I'm looking at how attractiveness and sense of humor work together to influence the likelihood of being asked out on a date. Now, looking at a different example, here's one example of a factorial design. And for this study, we're looking at whether having a dog versus not having a dog influences happiness. We also want to know how level of commitment influences happiness. And we can see if there's an interaction between the two. So if I'm looking at the main effect, I'm only looking at overall, does having a dog increase happiness? That's one main effect. My other main effect is I'm only looking overall, how level of commitment influences happiness. And then my interaction is looking at how having a dog changes happiness dependent on whether they're dating or married. So it's dependent on their level of commitment. How does one independent variable influence the dependent variable based solely on one level of that other independent variable? So this is a 2x2 design. So you'll see there's 4 conditions here. One group is no dog and dating, another group is dog and dating, another group is dog and married, and another group is no dog and married. Now, to remind you, this is pretty much not a manipulated variable. You could manipulate the dog, but it's really hard to manipulate dating and married ethically. I want to remind you, for your study, it is going to be at least one independent variable that is manipulated. So you as the experimenter controls who gets what condition. Notice that if you add levels, it makes it a more complex design. So if I had maybe a dog, no dog, and then 2 dogs, that would now make it a 2x3 design. So there would actually be 6 conditions. And maybe if I made it 3 levels for commitment, dating, married, and single, that would now make it a 3rd level. So if I had a 3x3 design, there would actually be 9 conditions. So every time you add a level, you obviously are adding another group of conditions that you have to account for. So every time I add one condition up here, I have to actually add 2 levels because I need that condition for dating and that condition for married. If I'm adding what's it like with 2 dogs, I need to look at, well, now people who have 2 dogs and are dating. What's it like with 2 dogs with people who are married? So you're not just adding one condition to one group when you add a level. You actually are adding more than one condition at a time because you have to account for the second independent variable. So there are 2 types of information that you will be looking at and discussing in your paper for factorial design. You'll have main effects. The number of main effects in your independent variable will equal the number of independent variables you have. So you'll have one for each independent variable. And you'll have interactions. The interactions will be the effect of one independent variable on the dependent variable based on the level of that other independent variable. So the number of interactions actually depends on how many independent variables there are, but it's different. So if I have only 2 independent variables, I can only have 1 interaction.